This video is on compounding continuously. This video will make the most sense if you watch it after the 10.8 video in which you learn about the irrational number e. We have learned already how to do compound interest when you're compounding a finite number of times per year. You got a equals p times 1 plus r over n to the nt power, where n was the number of times per year, so n could be 12 if you're compounding monthly, 52 if you're compounding weekly, 365 if you're compounding daily. There's another concept analogous to that called compounding continuously, which means it's not a finite number of times per year, it's essentially an infinite number of times per year. And that formula is a equals p times e to the rt power, where e is that irrational number that's approximately 2.718281828459045. So how do we use this formula? Here's two examples. The first one, Carol is going to invest in an account paying an interest rate of 5.2% compounded continuously. How much would Carol need to invest to the nearest dollar for the value of the account to reach $940 in 6 years? So we know it's compounding continuously. That means we're going to use this formula, a equals p e to the rt power. A, p, r, and t mean the same that they mean for the other compound interest formula. So we want the value to reach $940. We want to know how much she needs to invest. So what are we solving for? We're solving for p, and we know that a is $940. We want to know how much she needs to start with, the principal amount, so that she ends with $940. E is not a variable, it's a number. It goes in there, into the formula. R is our rate, our annual rate as a decimal. So 5.2% we're going to express as a decimal, 0.052. And T is the time in years. That's 6. So we can multiply the 0.052 times 6. We get 0.312. So 940 equals p times e to the 0.312 power. I can do e to the power of 0.312. E is a button on my calculator. It's above the ln button when I want to do e to a power. I get approximately 1.366154693. I'm going to go all the way because this is not my final answer yet, so I don't want to round anything until my final answer. And then to solve for p, I'll simply divide 940 divided by that. Let my calculator do that work and get me 688.06 dollars. That's how much Carol needs to start with so that she ends with $940 in 6 years. Now, I did say to the nearest dollar, so to answer that directly, we would say 688. Rounding it to the nearest dollar would round it down because 0.06 is less than 50 cents. How about example 2? Alex invested $54,000 in an account paying an interest rate of 4% compounded continuously, assuming no deposits or withdrawals are made, so he doesn't add any more money and he doesn't take any money out. How long would it take to the nearest year for the value of the account to reach $106,200? Compounding continuously is our signal to use that formula, a equals p e to the rt power. He's investing $54,000. Is that a or p? That would be p. And what is a? That's the amount he wants to end with, which is $106,200. P was the $54,000. And we got e, which never gets replaced with anything because it's an actual number. R is our rate, which is 0.04 as a decimal. And t is the number of years. That's what we're looking for, how long it would take to the nearest year. So that's what we're solving for. Okay? So we want to solve for t. T is stuck in the exponent. Let's first divide everything by 54,000. Divide both sides by that so that we can get the exponential part isolated. So we get about 1.96666666667. So e to the 0.04t power. Okay, how do I solve for t from there? I need to convert to a log. What log do I use when my base is e? I use an ln. So I'm going to convert that equation into this equation, the ln of that decimal, which I'm going to use the whole fraction just so that my calculator gives me as high of an accuracy as possible, 106,200 over 54,000. And that ln, which is a log with the base of e, equals the exponent that I had before, 0.04t. So to fully solve for t, I'm going to take that ln of 106,200 over 54,000, and I'm going to divide it by 0.04. I'll let my calculator do that. There's an ln button on my calculator, and then I will divide by 0.04 after I do the ln. I get 16.9, and then it asks me how long does it take to the nearest year. I'm going to say about 17 years for that money to go from $54,000 to $206,200. And that's how we do compounding continuously.